Lugares são como pessoas. Tem aqueles que apenas passam por nossa vida e aqueles que deixam a sua marca. Tem aqueles sem graça e aqueles instigantes. Lugares são como pessoas. Tem lugar que tem um incrível poder de dar um clique na nossa alma. E quando a gente vê, já entrou no nosso coração e ele está ali, instalado. Salvador é assim. Uma festa para os sentidos. O gosto do dendê fica na boca, quase como uma tatuagem no paladar. O cheiro do mar não se contenta em ser sentido. O sal gruda no corpo e quer se misturar com o nosso suor. As imagens são tão carregadas de sentido que parecem ter sempre algo novo para lhe mostrar, mesmo que você já tenha visto dezenas de vezes. E a batida? Será que é por acaso que tem o mesmo nome daquilo que lá no peito faz a gente se sentir vivo? Uma cidade que é dividida em duas partes e ligada por um elevador não nasceu mesmo para ser convencional. Aqui, o palco anda. E o mais impressionante, o povo sai andando atrás. Aqui o banho pode ser de mar, mas se preferir, pode ser de pipoca também. É o coração da África, o berço do Brasil e tem o sorriso que é do tamanho do mundo. Só quem nasceu de uma mistura pode juntar tão bem coisas tão diferentes. Salvador tem um santo do candomblé para cada dia da semana e uma igreja para cada dia do ano. Salvador é superlativa, generosa, bem-humorada e de bem com a vida. Não dá para ser o mesmo depois de conhecê-la. Não dá para ser igual depois de sentir suas sensações. Não dá para ser igual depois de perceber suas singularidades. Não dá para ser igual depois de sentir seus cheiros, ouvir seus sons, provar seus sabores. Não dá para ser igual depois de ouvir suas histórias. Não dá para ser igual depois de conhecer um lugar tão surpreendentemente diferente. Salvador, você sente que é diferente.
Good morning, João.
Good morning, Louzada.
Good morning, everyone. Welcome to the third conference on Statistics and Data Science. We're very happy to have you here today.
Welcome back, everyone. Thank you all for attending this beautiful event.
I hope you have enjoyed our poster session. It has been great. We'd like to thank all of you who were part of it.
And a special thanks to all of you who submitted your work to our conference.
We made it to our last day of CSDS 2021, but it's not the end yet. Today we'll have 2 more presentations and a short course. Let's enjoy it.
It has been really great to have you all accompany us through these 3 years, these 3 awesome days, Thank you all.
Yes, and start the last day, I would like to introduce our first keynote speaker of the day, Dr. Francisco Louzada. Dr. Francisco Louzada is a professor of statistics at the University of São Paulo and director of the Center for Mathematics and Statistics Applied to Industry. He obtained his PhD in statistics from the University of Oxford. His main interests are data science, risk analysis, and statistical inference and its applications.
In his presentation called Reliability in Brazil, Roads for Approaching Industry, Dr. Louzada will talk about some reliability innovation projects, showing how a connection road between academia and the industrial, medical, and financial sectors has been created. We would like to thank and welcome Dr. Francisco Louzada.
Welcome, Dr. Francisco Louzada. It's an honor for all of us.
Good morning, everyone. Well, it's an honor for me for having me here. I'd like to thank you, all the organized committee, particularly Paulo, Canas Rodrigues that have invited, but Lisandra, João Vitor, and the others. So for me, I'm very pleased to be here in this morning to talk to you about reliability in Brazil and roads for approaching industry. I'd like to know if my presentation, it's okay for you.
Yes,
I will
yes,
change.
everything's okay.
Okay, everything okay. Okay, I will change. It's changed for you.
Yes.
Okay, that's fine. So my objective here, it's I have 4 different objectives here, but particularly I'd like to show for you the Center for Mathematical Science Applied to Industry, where in nowadays I'm one of the directors of the center, to point out our main actions and activities relate to the technology transfer to create connection road between academy and industry. I point out the reliability innovation projects to have run with some industries. Particularly, we are directing this talk for modeling of oil well construction equipment, fraud detection, communication modeling for mobile phone, and a bucket track equipment. I could say it's intelligent bucket, really. Well, this is the outline of the talk. Particularly, I'm going through the motivation for the creation of our center, the need for product development based on mathematical science, some activities that we are developing at our center, point out some impacts on industries and society, and discuss about reliability directed to industrial problems. First, I'd like to say that, of course, mathematical science are very important in our lives. Well, they light up our daily lives. They direct us to understand what happened around us. And particularly because from the moment we wake up, we are tied to numbers. So mathematical science are essential for us to understand the phenomena that sound around us and increase our knowledge about them. I'm saying not only about statistics when I'm saying about mathematical science. I'm saying about applied mathematics, statistics, and computing. So all the research that have been working in these areas, we include as mathematical science scientists. And particularly, our center is very worried about education and how we can communicate what we have done inside the center. So, I mean, if you point your camera to the QR code that is in the slide, it's possible you reach all the news that you have inside our center. And particularly nowadays, we are contributing for giving more information for people about the research that have been developing in the universe, particularly in our center. One example that it's important to show for you is the InfoTracker, which is a system that provides data on the progress of COVID in the São Paulo state. So the tool presents data from various cities in the state. And particularly nowadays, it is very useful, and a lot of governmental staff have been considering the information that the InfoTracker give to take different decisions about what they have done in the progress of the COVID. Another example is the safety stock, which is a tool that has the objective of building predictive models for the demand of personal protective equipment in Brazil, hospitals during the COVID-19 pandemic. Well, this is a particular project that includes the researchers from our center and from Bionexo, which is a company that deal with personal protective equipment. And the project is very important. This platform is very important because it allows the exchange and cooperation between hospitals, maximizing care during the pandemic. If you are interested in the results related to that, and if you are interested to know which kind of modeling we have been using there, just point your camera to the QR code and you can get directly to the Media RX archive where our working paper is. So, I mean, you have done this in Brazil, and after that, repeat that for Argentina as well. Also, we could say that mathematical science are important not only for us as person, but for industry as well. Since mathematical science promotes innovation, and that improving process, products, and service, allow the reduction of operational costs, increase employee analytical skills, and promote industrial innovation as well. We don't have this kind of study in Brazil, but we have this kind of study in France and England. It's a study related to know which is the importance of mathematical science to the gross domestic product. So in France, they have done this research and they discovered that estimated the 50% of the gross domestic product comes from the mathematical science. In England, the same thing is about 6%, and 10% of the jobs vacancies comes from the mathematical science. Also, we realized a few years ago that most countries that have achieved high levels of development and innovation have institutions that promote the use of mathematical science as a tool for technological development. So think about that. We decided to propose a Center for Mathematical Science Applied to Industry in Brazil. You can see that, all the Center for Mathematical Science Applied to Industry are in the developed countries. And so we decided to create CMI in Brazil, and now we have the CMI, and after 7 years, you have another one, which is the PI Center in the INPA, which is the Institute for Applied Pure and Applied Mathematics. So, I mean, in Brazil, you have these two centers that are related to mathematical science applied to industry. We have another one in Chile, but it's a little bit more focused in engineering. So, just seeing some history about our center, in 2011, we created the center, and in 2030, you got a huge project from the FAPESP, which is one of the governmental source of funding for us. And you have a project with them. We are in São Carlos, but you have researchers from all different parts of the São Paulo state. And they give us, in the first period, which was a 6-year period, budget of 15 million reais to make this relationship between academia and industry. And now we have 30 million until the 2024. So our general objective here is to promote the mathematical, the mathematics, statistics, and computer in the productive sector, encouraging interdisciplinary cooperation. And our mission is to work as an interlocutor between academy and industry, promote interaction between research and professionals from the productive sector. Our focus here is to be an active agent in the formation of new talents in the mathematical science, provide education, technology transfer, and innovation. And inside of our center, which you call here, I would say before, but it's the acronym for our centers is SEMI. It's SEMI. So we have several actions and activities related to the transfer of technology and innovation to reach industry. So we foster relationship with public and private industry and institutions. Through our workshops, we develop technological products and products based on mathematics, statistics, and computing. We serve research industries and the institutions in our technological clinics, and you offer different types of training courses for professionals and industries through our corporative education. So we have been working on a holistic structure to reach industry, in the sense that you get the industrial problem. After that, I will say to you how we will do this, and you bring this problem to inside the university, start the analysis and the development of new methodologies or the application of the methodologies, solve the problem. And after that, you return the results to the industry through technological transfer. But we realize that some industries don't have professionals that have knowledge enough to use our developments. So we introduce in the middle of our analysis development and our technological transfer a corporate education structure. So we give education and training this professional to use what we have developed inside of the university. So the question here is, how do problems and projects reach SEMI? This comes via technological clinics, in-loc workshops that we have done, and studies group with industries. So we have workshops focused on industrial problems, and we promote workshops direct to solve the industrial problem. And you call this Brazilian study groups with industry. The study group with industry is not a new idea. It's a common practice in other countries, and it was originated in the 60s in UK. And the basic idea is to bring together mathematicians and industry professionals to work side by side to solve real problems that companies face. So, I mean, we have, since we have started, we already have 6 editions of this Brazilian study groups with industry. And before the study group, which is a week working together to solve the industrial problems, we have schools of applied mathematics, and we have almost 3 courses in each one of them. One course of statistics, another course of mathematics, applied mathematics, another course of computing, and but just providing the students with the theoretical argumentation that they probably will be used during the next week, which is the workshop, the Brazilian study group with the industry. In the 6 editions, we have several industries that have been collaborating with us, bring problems to be solved inside the workshop. Up to now, we have solved the 39 problems from 31 industry and institutions, and almost to have about 130 delegates by edition. The last one, it was online edition. We have a little bit more of delegates, but the advantage of that, we have delegates from different states from Brazil and from different countries as well. So for us, it's very important, and you saw that as an opportunity to spread this kind of workshop. So by the end, this one was run in March this year, but in March, and in September, last September, we run the 7th edition, which was in IMPA, which is the Institute for Pure and Applied Mathematics. We made a collaboration and run the 7th workshop with these industries and institutions. Well, also have the in-loco meetings. So we go inside the industries to see which kind of problem they have and how we can use mathematical science to solve them. And these are some of the industries that we have been visited and made some partnership with them. And also have the technological clinics. We have the mathematical clinic, the statistical clinic, and the information technology clinic. So in this sense, the companies in the research are welcomed by a team from the research, from the different areas of the SEMI. We understand the problem or the project and forward it to the center research group for a solution, or at least a quick solution for their problems. And also have the corporate education. We have different kind of course, and particularly you have a professional master program, and a MBA in data science. So the master program, it's a professional one, and is the unique in Brazil. Is this characteristics is a master, it's a professional master degree in mathematics, statistics, and computing applied to industry. And you already have 8 editions. Each year you have 1 edition. The first one was in finance, and the others were in data science. And one difference of our master degree is that the student can bring a problem from his industry to be solved as his dissertation. And so we have a chance to provide education for the professionals from the industry, but also transfer knowledge from the university to the industry through their dissertations. We already have employees from more than 50 industries and institutions that have been studied with us. But by the way, this professional master degree has a limitation, that is the number of the students. We have just 50 to 20 places for a year. So in order to have to reach more individuals, we created the MBA in data science, which has the same argumentation of our master program. So I mean, the students can bring a problem to be solved inside the university through the final project, and up to now have served more than 450 employees from more than 250 industry and institutions. So we could say that you have several evidence and results relate to the activity that you have run inside the center. So we have more than 100 partners, more than 200 appointments in the technological clinics. We have had 7 workshops, more than 200 meetings in local meetings with industry, more than 130 projects, and the master degree and our MBA in data science, we have served more than 500 employees for more than 300 industries. So as a result of these activities, we already have 2 spin-offs from our center. We have more than 30 agreements for academy industry collaborations. We could obtain funding from these agreements, and also we have more than 20 softwares and 4 patents. And you can observe different impacts in society and industries. Particularly, you could say that you have cultural impacts, since our actions and activities promote the improvement of our partner knowledge in making evidence-based decisions. We have social evidence impacts, since our actions and activities promote opportunities for developing and improving of public resource, and they also have financial impacts, since our activities and the actions promote process optimization, cost reduction, improvement of service level, and product quality. As an example, we made a survey that was conducted with our MBA ex-students in data science, and you discover that in the student career, 29% of them report salary increase due to the new training. 90% report promotion or got managerial position. 57% report training obtained in the MBI was decisive for promote to a new position, and the 24 got a better job. In terms of industry and institution, 29% report increase in production or increase in profit. 66% report development of a new product or service and service. 58% indicate the adoption of new methodologies. 63% indicate the increase in the production of service in product and service portfolio, and 30% indicates that they have production optimization. We have different kinds of evidence that it's obtained from our actions. Now, we'd like to show you in which areas we have projects inside the semi. So in all these different areas, you have some different projects: oil, gas, finance, government, technology, sports, health, sustainability, education, and the agribusiness. Particularly in reliability and survival analysis, which I'd like to focus here, we have projects in industrial, medical, and business sector. Particularly, I'd like to show the deep water oil exploration field from Petrobras. And, it's possible you realize that the oil is catched in the pre-salt layer. And, you have different wells that needed to be built to push this oil. And the problem here is that we have a safety valve that is a critical component in the production column and mandatory in the exploration wells. And you put this valve here, It's called the downhole safety valve, DHSV, and it increases the operational safety in order to avoid eruptions or uncontrolled flows from the well, prevents the environment. And currently, the valve has a reduced reliability and high failure rates. So, you can say here that you have in a population of a little bit more than 350 valve in deep water. For the Petrobras, we have 64 defects and 49 fails. So we have a project. It's called Reliability of Oil Exploration Well Equipment. And this project is for improving the valve reliability, investigate failure and assist supplier to improve the quality of their products, and develop knowledge and requirements for validation and testing. I also have another project with them. It's called Janelid, which is a robotic unit for clean ducts. So the context here is that in the oil industry, lose billions due to loss of profit associated with interrupt production lines. Flow assurance solutions are complex and cost millions of dollars annually. So, this is a kind of interruption that occur in the line, and this is the project we are in, is the development of a robotic unit for inspection and clean ducts. It's a 15 meters device. And the idea here is guarantee the reliability of this device. The annelid, we call it, it goes inside, and our objective here is to live inside the ducts, and after that it needs to get out. We don't want that it is thick inside. So it's a high innovative and complex project that need a lot of reliability. So we have inside the SMI a risk modeling team with a multidisciplinary structure which is capable of working on different work fronts. Particularly have guys from research from applied mathematics, statistics, and engineer with complementary skills. And our approaches work in an integrated approach to risk analysis, supported by statistical models, simulation and tests, aiming to obtain a high reliable product. So, I mean, the idea is that since we have the design, the product, we start with our actions to have a reliable product. So the feeding of the statistical model is use the external database, data simulation from statistical modeling according to some criteria of interest, particularly using which the engineers call failure tree analysis and the failure modes and the active analysis. Data simulation using computer-aided engineer tools, which take into account physical and mathematical modeling, and use also real data from in situ tests. Well, I just focus now on the Annelida. You can realize that, you have different kinds of groups work together. We have 6 groups work together, and we are responsible for reliability of the Annelida. So, I mean, in the duct, we have something like this is the hydrated paraffin formation. And as the time goes by, we have a formation of hydrates and paraffins, and have an obstruction in a duct. So we have a control room, we have which you call umbilical cable, and you have a release system that are being building now. And the idea is that through these structures, we release the Annelida inside the duct, and the Annelida goes until the obstruction, and through nitrogen generation, it cleans the duct. We have several stress conditions, particularly have the operational dip up to 300 meters. The temperatures go from 4 to 6 degrees and Celsius, and pressure is up to 250 to 2050 psi. So our contributions for this project is planning and evaluating simulations, models, and tests, analysis and quality assurance and project reliability, development of models to quantify and improve reliability. We have different kinds of models that have been using here. Particularly, we consider in this situation a non-homogeneous process intensity function, but you have a repairable system subject to hierarchical competing risks. So this was a paper that was published in IEEE Access, and we have different kinds of papers that have been accepted. And now we are working on different kind of model. Particularly, we need a Bayesian statistical modeling for that. We need a accelerated lifetime test for that. We are working on that, and we are working as well on degradation models. And we are very happy with this project because we have the opportunity to be chosen as the top 3 in the National Petroleum Agency Technological Innovation Award the last in 290 and the last year as well. Also have different kinds of studies. This in the finance, the statistical modeling for fraud detection. Since I think that I advanced a little bit in the time, I just pass to you this problem we have basically bank loans, and the idea here is to discover that you have default. Default is very important in Brazil. Something about 5%, 6% of the loans in the loans who have default. And in the fraud modeling here, we realize that it's a very complicated problem to be solved, and you have few short time to solve the problem. So it's we could say a volatile event. So you have a few days to solve the problem. If you don't solve the problem, the frauders come inside the database, go there, do what they need to do, and leave with the involuntary churning. So I mean, we need to be careful to do this kind of model. So we provide a model for them that you can discover the fraudsters directly through the strike to the full individuals. We modeling the defaulters, and we modeling the no susceptible defaulters as well. We have several papers on this kind of problem. If you are interested in that, please just send me an email. I will be happy to share with you a copy of these papers. Another problem we have with the communication modeling for mobile phones. The idea here is to keep stable communication between the antenna and the mobile phones by using efficient embedded technology. So in this case, you are using the Nakagami distribution, which is a powerful statistical tool in communication area. They use this distribution to model the amplitude of the received signal. And we have here a problem with the fading parameter. And depending on the fading parameter, you have different shapes for the density of the amplitude density. The problem here is that several methods have been considered to make to derive efficient estimators, but none of them produce unbiased estimators, which could be calculated in real time. That you need that because you have embedded technology. So propose a model here that this model has a simple closed expression. It can be calculated in real time, and it produces almost unbiased estimation for the fading parameter, which we have interest, even for small and moderate samples. So here we have some information about the error that's committed with our method. Our method is much better than the usual ones. Also have a lot of papers on that. Please just send me an email if you'd like to receive information about that. And by just to finish, we have a smart bucket, which is a urban waste monitoring system. So worldwide, we could say that the generation of waste is equivalent to 2 billion tons per year. The problem is worse in Brazil. Since you have improper waste disposal, obstruction of roads, floods, contamination of water resources, proliferation of diseases. So using our technology, the system is capable of carrying out waste management tracking bugs, they inadequate loads and dumps. The system helps in the environment management of the waste disposable in landfills, and it automates inspection of waste disposal in appropriate locations. So we have several differentials. The technology allows solid waste tracking to be full automated without operation handling. Manual interference only occurs to position the bucket on the truck. This system can monitor the location of each bucket, loading, transport, and disposable times. So because that you use reliability here, the places where the items were discharged, and track the path traveled. So this kind of bucket, which is a smart bucket, it assists in decision making and in carrying out diagnosis of possible problems. So this is the processing scheme that is proposed, and now we submit a patent. This is the patent number for this smart bucket. So I mean, this is what I need to say. I'm not working alone in this kind of projects. So this projects about reliability that I'm saying, we have 20 students and researchers work together. In our center, we have a huge team with 34 principal investigators, 79 associated investigators. We have several partners, so I need to say thank you for them, because from them it's possible to have the opportunity to work in their problems and give solutions. And by the end, I would like to say that to reach the industry, we need to go along several roads at the same time. So we need to look for its problems, offering solutions, transferring technology, and provide education all at the same time. So we, inside our center, we keep walking along these roads, adding knowledge and implementing solutions. Well, this is what I'd like to say for you. Thank you very much for listening and giving me the opportunity to show a little bit of our center and how you use our structure to transfer technology based on reliability for industry. If you'd like more information from us, please just go through the social medias that we are in YouTube, Facebook, and Twitter, or you can get your camera and go directly through this QR code to our homepage. Thank you very much again.
Hi, I would like to thank Dr. Louzada for this great presentation. It was an honor for us.
Thank you, Dr. Louzada. And I believe we have a couple of minutes for one question. Here we have, and I apologize for the pronunciation on the name. I don't know if I'm pronouncing it correctly. It's Kenhid Abimbola. How can we benefit from the CMI as mathematical scientists?
Well, you know, if you are a researcher from CMI, or if you have some relationship with some researchers from CMI, it's possible you can have some exchangeability. So it's possible you can bring you to Brazil, or you can send somebody to there. I'm not sure from which place are you?
I don't think we have this information.
All right, okay. So I mean, it's possible it's possible for us to make this kind of relationship and produce research based on real problems, on industrial real problems. So this is a very important thing that you can provide for the mathematical scientists.
Okay, I believe that we have one more comment here. Alberto Rodrigues said it was a great presentation. It was a great presentation indeed. And now I would like to thank one more time Dr. Louzada. It's a great start to our last day, and thank you. It's an honor for all of us.
Okay.
Thanks,
Thank you
Dr.
very much.
Louzada.
Thank you very much.
And now we'll be moving on to our next talk of the day. Is our second and of the day and the last talk of the day. And the link will be in the YouTube chat, and I'll see you there. You can find the link also in the website. So thank you and see you there.
Thank you. See you all there. Bye-bye.